Bright Duty. Every student matters.
Now we are going to discuss about the concept that is least common multiple I say or lowest common multiple we say. So by the word we mean common, that means we have more than two numbers. We are going to take out their multiples and we will find out common of all the multiples, and out of those the smallest one, the minimum one would be the LCM, also known as lowest common multiple. So let us just try it for some numbers. So let's take an example where we have the number as suppose 4 and 6. Okay, write down the multiples of 4. 4 multiples are 4, 8, 12, 16, 20, 24, 28, 32, 36, then we'll have 40, 44, 48, and like this. Now 6 multiples, if I write 6, 12, 18, 24, 30, 36, then after 36 we will have 42, okay, then we'll have 46, 54, and up to so on. So let's see what is the common multiple. What are the common multiples? So the first multiple that I see is common is, okay, this is common. So 12 is common to both of them. After 12, if I see that which is the common one, 24 I see that is common in both of them. And after this we have, okay, I wrote it wrong. After 42 it should be 48. 6 8s are 48. So then 48 is common if you see. Okay, so like this there will be infinite number of multiples that will come out common, because multiples are non-ending, they do not end anywhere. So out of the common, like we see the common ones are, if I write the list of common multiples, that is 12, 24, okay, then 48. We also have 36 as common if you observe, right? So we have 36. Out of all of these, like this list will not end, out of all the common multiples, students, which one is the smallest one? We say 12 is the smallest one. So I say the LCM of 4 and 6, or I say the least common multiple of 4 and 6, we write like this: LCM of 4 and 6 is 12. So this is one way of finding the LCM. Okay, you write all the multiples like if we did in HCF. We wrote all the factors, and out of the factors, the highest one we took. So we calculated HCF. In LCM, we will write the multiples. We'll take out the common multiples. Out of the common multiples, the smallest common multiple will become our LCM. We have certain other ways to find out LCM. We'll figure them out. So what basically is an LCM? The smallest common multiple. Least means smallest, lowest means smallest. Okay. So suppose we have to find out the LCM of 12 and 18. So we have another way of doing it. So I will not do it with the same method that we have discussed. Let's discuss an alternate to it, another method to it. So I will express 12 as the product of prime factors. 12 if I write, I'll get 2 6 are 12, 2 3s are 6, and 3 1s are 3. 18 also if I express in the form of prime factors, 2 9s are 18 and 3 3s are 9. Okay, so 12 is equal to 2 into 2 into 3, and 18 is equal to 2 into 3 into 3. So 2 is coming 2 times, 3 is coming 1 time here, but in 18, 2 is coming 1 time and 3 is coming 2 times. So what is the format? How do we find out? What is the way to find out the LCM? You have to take all the prime factors that are occurring in 12 and 18. We see there are two factors, that is 2 and 3, which are there in them. So we have to take all. Okay. Now we have to take it the one coming maximum number of time, like 2 is coming 2 times in 12 and 2 is coming 1 time in 18. So I will be taking 2 times, the greater one. Similarly, 3 is coming 1 time in 12, 3 is coming 2 times in 18. So you take the one in which it occurs maximum number of times. So 3 occurs maximum 2 times. So 3 into 3 you will take, and you will multiply these 4 and 9, 36. So the LCM of 12 and 18 will be 36. You can also find it by writing all the multiples of 18. Write down all the multiples of 12. Take out the common ones. You will find 36 would be the first one, or the smallest one that would be common, and that will become your LCM, the least common multiple. This is another way of finding it. You write 12 and 18 as the product of prime factors. Now we will take all the prime factors that are involved in the prime factorization of 12 and 18. How do we take them? We take them as, we take maximum number of time they occur. Like 2 is occurring here in 12 maximum 2 times, and in 18 1 time. So what is the greater one? 2 times. So we have taken 2 times 2. 3 also we have taken 2 times, because that is the maximum number of time it occurs. So always you have to see the maximum number of time that particular prime factor is occurring. Let us proceed. Suppose we have this. Let's do this also with the prime factorization method. So if I have 24, expressing it as the product of prime factors, 2 1s are 2 2s are, then 2 6s are 12, 2 3s are 6. This is how we write 24. 90 if I find, I'll start with 2 4s are 8 and 2 5s are 10. Then with 3, 3 1s are 3 and 3 5s are 15. With 3 again, 3 5s are 15. Okay. 24 can be written as 2 into 2 into 2 into 3. And 90 can be written as 2 into 3 into 3 into 5. So student, what would be the LCM? You notice the prime factors that are there. They are 2, 3 and 5. There are 3 prime factors that are occurring. Now 2 is coming how many times in 24? 3 times. And it is coming just 1 time in 90. So we will take it 3 times. Maximum number of time we take it. So 2 will be taken 3 times. Then 3 is coming 2 times in 90 and 1 time in 24. So we'll take it 2 times. Okay, maximum number of time it occurs. 5 is coming 1 time here and it is not at all here. So we'll take 5 as 1 time. Now multiply. 2 into 2 into 2 is 8. 3 into 3 is 9 and 5. 8 into 5, if I multiply, I get 40 into 9. So the answer is 360 after multiplication when you solve. So the LCM of 24 and 90 is 360. This will be the first common multiple of these both, or I say the smallest common multiple of these two. So suppose if I start writing the multiples, I have to make a long list and then I have to take out the common thing. That is going to be a lengthy method. So it is preferred. Everybody prefers, most of the students prefer doing this. So we can follow this method for finding out LCM. Just take care, you are going to take all the multiples that are occurring, all the prime factors that are occurring in the prime factorization of the numbers, and you have to take the maximum number of time they occur. Clear? So this is how we find out the least common multiple. We have one more way of figuring out how the LCM thing works. So we can also find LCM using one more method. Let's try that out. Before doing that method, let us practice one more question. If we have more than 2 numbers, how the prime factorization thing is going to help us in finding out the LCM. So for 40, let's do the prime factorization starting with the smallest prime number, that is 2. So this is how we will get it. Correct? For 40 we have done. For 48 now we will do 2 2s are 4, 2 4s are 8, then 12, then 6, then 3, and at last 1. Quite easy to do. 45, you know, is an odd number, will be divided with 3, not with 2. So 3 1s are and 3 5s are 15, then 3 5s are 15 and 5. So let's just write them. So 40 is equal to 2 into 2 into 2 into 5. 48 is equal to 2 into 2 into 2 into 2 and then 3. Then for 45 we have 3 into 3 into 5. Okay, so as I told you that we have to take all the prime factors that actually occur in them. The prime factors I can see is 2, 3 and 5, but we have to take them as the number of times they occur, maximum number of times they occur, that we will take. So let's think about 2 first. 2 is coming 3 times here, 4 times in this, and not at all in 45. So maximum it is 4 times. I'll write 2 4 times like this. Then I come to 5. 5 is coming 1 time here, 1 time here. So maximum it is coming 1 time. And if I talk about 3, 3 is 1 time here, but 2 time here. So 2 times we will take it. Now students, we are going to multiply it. Just see, 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16. So I am writing 16 into 5 into 3 into 3 is 9. Okay. So we have 16 into 5, that is 80. So I am writing 80 here. Okay, into 9. So multiply it, you get 720. So the LCM of 40, 48 and 45 is 720. Now see, this is a big number, 720. So you had to write, if you would use the first method in which we were writing the multiples and then we are taking out the common multiple. So that would be very lengthy and time consuming. Instead, if we use this method of prime factorization to find out the LCM, it is going to be easy and less time consuming for us. Clear? Let us discuss the another method of finding out LCM. Okay. Now, if we have to find out the LCM of 20, 25 and 30, how will we do it? Let's do it. So the method is to be followed like this. We make a line like this. Okay, and we write all the 3 numbers with some gap in between. We write like this. Okay, you can put a comma in between. Also, we can write like this with some space in between. So first of all, you should see that if out of the 3, there is any number that is divided with the least prime number. The least prime number or the smallest prime number is students 2. So yes, there are numbers that are divided by 2. So we will divide them. 2 ones are 2 and 0. Okay. Now 25, because it is not divided with 2, you copy it as it is in the next line. Okay. And 30 is divided by 2, we get 15. Still we see 10 is multiple of 2. It can again be divided with 2. So you keep doing it till the time you are left with no multiple of 2. Okay. First we have to finish the multiples of 2. 2 5s are 10. 25 because not getting divided with 2 exactly copied here. 15 same case. Now let's come to the next prime number, that is 3. Do you think out of 5, 25 and 15 any number is a multiple of 3 or can be divided by 3? Yes, it is 15. So I'll start with 3. I'll copy 5 as it is because it is not getting divided with 3. 25 also will be copied as it is. 3 5s are 15. Now 5, 25 and 5 is there. So now out of all 3 there is no multiple of 3. They will not be divided with 3. So I'll start with the next prime number, that is 5. So we will get 5 ones are 5. 5 5s are 25. 5 ones are 5. Again we are left with 1 5. So we will divide with 5. You see at last we are getting 1. So we need to stop here. Now how do we find the LCM? You just multiply these. Okay, so LCM will be 2 into 2 into 3 into 5 into 5. So we are going to multiply them. Solving it, just see 2 into 2 is 4. 4 3s are 12. 12 5s are 60 and 60 into 5. We get the answer as 300. So LCM of 20, 25 and 30 is 300. Okay, let's now do some application based questions, some real life problems on HCF and LCM. Okay, focus on this one. It is saying there are 2 tankers. What we are given with 2 tankers and what is the capacity? One has 850 liters capacity and another has 680 liters of kerosene oil respectively. So there are actually 2 tankers, one and second. In the first one, the capacity or the I say the quantity that we have is 850 liters. Okay, and in the second one we have it as 680 liters. These are the 2 tankers given. Now we have to find the maximum capacity of a container, okay, which can measure the kerosene oil of both the tanker when used in exact number of time. So what is the question actually asking us? We have to tell the maximum capacity of one container if I am measuring it using that container. Okay, it should, measure it, the kerosene oil, the quantity when it is used exact number of time. What it actually means, let us just take a very simple example and understand it. Suppose I have here some 20 liters, okay, and here I have 10 liters, okay. Now I have to measure the capacity, I say, of both of the containers, find the maximum capacity of a container. So I will take one another container using which I am measuring the kerosene oil of both the tankers. So what I have to do, I will fill this container again and again, but it should be used equal number of times. So suppose it is of 2 liters. Okay, so how many times will I have to fill it from this? 10 times. Okay, and exact number of time I'm saying. And this one, 10 liter, if I have a 2 liter container using which I'm again filling and getting to know what is the total capacity or what is the total quantity in it. So that would be how many times? 5 times. So exact number of times we are saying, it is not 6.5 or 5.5, exact number of times, 10, 5, 7, like this. So now instead of 2, if I had 1 liter container which is having 1 liter as the capacity. So 1 liter, then 20 times I will fill from this and 10 times I will fill from this. What about 5 liters? Okay, if I take 5 liters container, then I will fill how many times from this one? 4 times. 5 fours are 20. 4 times from here, because when you do it 4 times, 5 liter, 5 liter, 5 liter and 5 liter, all 20 liter will be consumed. Similarly, from here if I say, it will be 2 times, and exact number of times you observe. Yes. So these are what? These are nothing but the factors 1, 2, 5. These are the factors of 20 and 10. Okay. But they're asking the maximum. So maximum means we have to go with the highest factor. Getting it? We have to go with the highest factor. So that means if we have to go with the highest factor and we have more than 2, or we have 2 quantity even, then what do? We find the HCF either using the prime factorization method, or we write the factors and take out the common one and we take highest of that. So similarly, the same concept we are going to use here. The question here is asking us, there are 2 tankers. One has the 850 liters of kerosene oil, second has 680 liters of kerosene oil. Now you have to find out the maximum capacity of one container, which is actually measuring, okay, the kerosene oil of both the tankers, and it should be used an exact number of times. So what we need to calculate in this is, we need to calculate HCF. Let's find out. So we will find out HCF of 850 and 680. Let's do the prime factorization. We'll start with 2. 2 fours are 8. 2 twos are 4. 2 fives are 10. Now it is not divisible by 2 because it became an odd number. 425. Is it divisible by 3? No. We'll start with 5. It is not divisible by 3. So 42 is there. 5 eights are 40 and 5 fives are 25. Again with 5, 5 ones are 5, 5 threes are 15, and then we have 13. Dividing it with 5, 5 ones are 5, then we are left with 3, so 5 sevens are 35. So 17 is a prime number, we know will be divisible with 17 only. Starting with this, 2 threes are 6, 2 fours are 8 and 0. Again with 2, 2 ones are 2, 2 sevens are 14, 0. Again with 2, 2 eights are 16, 2 fives are 10. Now again with the 3 can we do? No, we will be doing with 5. 5 ones are 5, 5 sevens are 35, then 17 only. So let us write the prime factors 850 and 680 as the product of prime factors. So when we write that, what are we going to get? 850 can be written as 2 into 5 into 5 into 17. 680 can be written as 2 into 2 into 2 into 5 into 17. Let's take out the common things. 2 is common, okay. Then 5 is common. 1 time 5 is common. 1 time 2 is coming in both. 1 time 5 is coming in both. And 1 time 17 is coming in both. So we know for HCF, what do? We take it minimum number of times. Like 2 here is coming 1 time and 2 here is coming 3 times. We take the minimum number of times. So it is 2. 5 is also coming 1 time in both of them, and 17. So 2 5s are 10. 10 into 17 gives us 170. So the maximum capacity of that container using which we are measuring the kerosene oil of both the tankers, 850 liters and 680 liters, should have the capacity as 170 liters. So this is the maximum capacity of that container. So whenever maximum would be asked, we are going to find out the HCF. Minimum or lowest or the lowest or the least, we find out the LCM. Let us discuss one more problem where we need to figure out that either HCF or LCM, what is going to help us. Let's do that. Read this question. It is saying in a morning walk, 3 persons step off together. Okay, they started together. Their steps measure 80 centimeter, 85 centimeter and 90 centimeter. These are the measurements of the steps they take. The first one takes the step and it is how much meter long, how much centimeter long? 80 centimeter long. For the second person it is 85 centimeter. For the third one it is 90 centimeter. What is the minimum distance? Minimum means least distance, lowest distance. Each should walk so that all can cover the same distance in complete steps. So complete steps we have to find out, like 7 steps, 9 steps, like that. In how many steps they will complete the minimum. For minimum we have to find out the LCM. Why are we finding out LCM? Because we have to find out the minimum distance. It should be completed in like exact number of steps, and same distance should be covered. So if same distance they are covering and it should be minimum, we are going to find out the LCM. So what we will do, we will find out the LCM of 80, 85 and 90. We know the prime factorization method. We also know this method where we calculate it like this. So starting with 2, because we know 80 and 90 are even numbers, so they can be divided with 2. So we will start with 2 and keep dividing it one by one. Also you can separately find out the prime factors of 80, 85 and 90, and then you can do it. Let's try it out. Starting with 2, I'll have 40 here. 85, because not getting divided with 2 as it is, I am going to copy it in the next line, and here I will get 45. Again with 2, because 40 can be divided with 2. So we will get 20, 85 and 45 to be copied as it is. Again with 2, because 20 I have. So dividing with 2, I'll get 10, 85 and 45 exactly to be copied. Again with 2, 2 5s are 10, 85 and 45 to be copied as it is. Now after 2, the prime number is 3. And we see 45 can be divided with 3. 5 copying as it is, not getting divided with 3 students. 85, is it divisible with 3? No, copying it as it is. 45, yes, 3 ones are 3 and 3 5s are 15. Again 15 we can divide it with 3. So 5 and 85 copying as it is, and 3 5s are 15 we will get. So we actually have 5, 85 and 5. So now I can divide it with 5. 5 ones are 5. 5 ones are 5. 5 sevens are 35 and 5 ones are 5. So the last number that we will take as the prime number is 17. So LCM would be equal to 2 is coming how many times? 1, 2, 3, 4. So I'll write it 4 times. Okay. 2 into 2 into 2 into 2 4 times. Then 3 into 3 2 times. Okay. And 5 and 17. Now what we are going to do, we are going to multiply all of these. After multiplying, we will get 12,000 240. So this is the minimum distance and it is to be written as centimeter. The unit is centimeter because 80, 85 and 90 is also in centimeters. So this is the minimum distance. They will cover the same distance in exact number of steps or in complete steps, like total number of steps would be a finite number. Clear? So same distance, we had to find out minimum as well. So we did LCM. Let's do one more question. Okay. So here we have to find out the least number. Least means the smallest number, students. Smallest number we have to find out, which when divided with, the number should be the smallest, and when we divide it with 12, 16, 24, 36, what does that number do? It leaves 7 as the remainder in each case. So let us find out one number which is smallest and exactly divisible with all of it. Okay, so if we do that, what we will get? We will get the least multiple or the least number which when divided by all of these leaves the remainder 0. And then we can figure out what can be done if we want the remainder is 7. So what we will do? We will find out the LCM to get at least the least number which when divided gives the remainder as 0. Let's first calculate that. So you will calculate it how? 12, 16, 24 and 36. So I am dividing it with 2 first. 2 6 are 12, 2 8 are 16, 2 1 are 2 2 are 4, 2 1 are 2, 2 8 are 16, again with 2. Okay, so 2 3 are 6, 2 4 are 8, 2 6 are 12, 2 9 are 18. Again with 2 I can go. 2 2s are 4, 2 3s are 6 and 9. 9 as it is and 3 as it is I have copied. Again with 2 because still we have one multiple of 2, that is 2. So 3, 2 1s are 2, 3 and 9. Others I have copied as it is. So now I see there are multiples of 3, 3 1s are 3, 1 as it is, 3 1s are 3 and 3 3s are 9. So the last prime factor would be 3 that we divide with and we get 1, 1, 1 and 1. So LCM would be 2 into 2 into 2 into 2. 2 is coming 4 times as you can see and 3 is coming 2 times. Okay, yes. So 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 3 into 3 is 9. So when I solve it, 16 into 9, we will get 144. So student, this is the number. When you divide it with 12, you know it is a square of 12, 144, exactly divisible by 12. 16 will also divide it exactly, leaving the remainder as 0. Same goes with 24 and 36. So this is the least number that we know which is exactly divisible by all of these. What if I want the remainder as 7? I can add 7 to this number because I want the remainder as 7. So it should be 7 more than this number. So if I add that, what is the number I will get? 151. 7 and 4, 11. 1 carry we take. So 4 will become 5. So 151 is the number. This is the smallest number, you know. When you divide with 12, it will leave the remainder 7. When you divide with 16, again leaving the remainder 7. 24, again leaving the remainder 7. And same goes for 36. So we were actually in search of the number which is smallest, which is actually least. And when we divide it with 12, 16, 24 and 36, it leaves the remainder 7. So first of all, we'll calculated the number, student, that is exactly divisible and it should be the smallest one. So we calculated LCM because LCM gives us the least common multiple of all of these. So I calculated LCM, we found it as 144. 144 is the number that is exactly divisible and leaves the remainder as 0 when divided with 12, 16, 24 and 36. But what do I want? I want the remainder as 7. So I will add 7 to this number. So 151 is the smallest number which when divided with 12, 16, 24 and 36, it will leave the remainder as 7. So this is all for this chapter, playing with numbers. Here we complete our chapter.